the law of sines can be used to solve a triangle as long as you know one side and any two other measures. So, for example, you could know one side and then you could know another side at an angle, or you could know one side and two angles. Okay, but law of sines uses a combination of sides and angles. So we have three possible scenarios that we can use when law of sines. First is angle, angle, side. AAS stands for angle, angle, side. It's the way that your triangle would look. It means that you have an angle and an angle, but then the side you have matches up to one of your angles. Okay, so you've got two angles next to each other with an adjacent side where that side matches across directly from one of your angles. Angle side angle is where your side is between. So for example, angle A, side B, angle C would be angle side angle. So the side appears between the two angles that you have. Then we have what's called the interesting one, i.e. the one that most students or teachers like to put on tests and that most students forget all about, which is this one, side side angle. Side side angle says that you have to have the angle opposite one of the sides. So you would have side side, say angle, or you could have side side with angle C, or you could have side side with angle A. Okay, it just depends, but the trick of it is you've got two sides that are being next to each other with the angle across from one of those sides. Now if that happens, it means that you have a variety of possible solutions. You could have no solutions, meaning there are no measures that you can put together that's going to give you a triangle. You could have one solution, meaning there's only one such triangle that this information would make, or you could have two solutions, meaning that you can make two different triangles to solve the problem, both of which giving you correct and exact answers. Okay? So when we're dealing with the side-side angle triangle, the reason why you have the possibility of multiple solutions is because sine specifically is positive in both quadrants 1 and 2. Okay? So if the sine is positive, say in quadrant 1, if you look at that triangle, you're talking about having a very acute small triangle. But if sine is positive in quadrant 2, well, now you're talking about having an oblique triangle, and the side-side angle is the only triangle where that may happen. So the way that it works is once you find the angle, you have to determine if there's going to be another angle that will look. So we have to remember that the sum of your angles has to be less than, or has to equal 180 degrees, which means the sum of any two sides or any two angles must be less than that 180 degrees. Okay? So let's take a look at a couple of examples here. It's going to be kind of the easiest way to walk you through what this actually means and how it actually works. So I have a triangle here. Notice I labeled it ABC. But what I did not do is put the information in. So this is one way you could see your problem where you're not given a triangle, or you are, but the information is given to you up top. Most of the time, if it's given to you in this form, you don't have the triangle, you would have to draw it yourself. But I wanted to go ahead and give it to you just so we had it. So here I'm telling you that you have side A is 200 meters. So 200 meters, notice I put it directly across from angle A. We're told that angle A is 32.76 degrees. And we are told that angle C is 21 C, and we are missing the angle. Okay. So if we look at the information we've been given, we have been given angle, angle, side. So here, this is an angle, angle, side triangle. So the first thing I would do, I've already been given two angles, which means I can find the third. Okay, so I want to recall that all angles must sum to 180 degrees. So what this means is that angle A plus angle B plus angle C has to equal 180 degrees. Well, I know angle A is 32.76 degrees. I don't know angle B, it's what I'm trying to find, but I know angle C was 21.97 degrees, and this should give you 180 degrees as a result. Therefore, when we sum it all together, we find out that angle B is degrees. So there is the first result that we have. Okay, we know that angle B now is 125.27 degrees. Now the next thing that we can do is we can use the law of sines in order to solve the rest of the problem. So we have the law of sines says A over the sine of A is equal to B over the sine of B is equal to C over the sine of C. So I can input into my law the information that I know. I know A, or side A, is 200, and I have the sine of 32.76 degrees. This is going to equal B, which is an unknown, over the sine of 125.27 degrees is equal to the unknown C over the sine of 21.97 degrees. Whenever you are working with law of sines, you want to use as much given information as you can. Okay, so what was given is all of A and the sine. So the first thing that I would do is I would find, say, C. So we have 200 over the sine of 32.76 is equal to C over the sine of 21.97. So in this case, C is equal to 200 sine of 21.97 over the sine of 32.76. So when you plug that in and solve, you come out with C being 138.3 meters. Okay, so here is our next result that we have for C, 138.3 meters. Now we just simply need to find B using what I have left. So again, I would use the 200 over the sine of 32.76, and we would say that that equals B over the sine of 125.27. So here we find that B is going to be 200 sine of 125.27 all over the sine. We found, since there were only 3 missing sides, we have found everything we need and thus completed our angle, angle, side triangle. Alright, so now let's take a look at another triangle. So this one here, notice the information's already been put in the triangle itself. And if you look at it very carefully, you'll see that we have side, side, and an angle. Okay? This means that we are missing side A, we are missing angle B, we are missing angle A, so we have to be able to find our missing angles. This also means that this triangle could potentially have two solutions. So we're going to talk about how we figure that out here in just a quick sec. The first thing we have to do, however, is we have to be able to input the information we have so we can see how to go about using our law of sines. So A and angle A are missing, so we know that we have A over the sine of A because we don't have any information there. I have B, so I have 42.1 over the sine of B. And then I have 34.2 over the sine of 45.6. Okay. So the first thing I would do is I already have a length here. I don't know anything about A yet, but I do have a length for B, so I would go ahead and find my angle. So I'm going to work with what I have here. So I've got the 42.1 over the sine of B is equal to 34.2 over the sine of 45.6. So here, in order to solve for my B, I have to do a little bit of manipulating. We need to rearrange or solve our proportion here, so you would do cross product. So this is going to lead us down to doing 42.1 sine of 45.6 is equal to 34.2 sine of B. Divide everything by my 34.2.1 sine of 45.6 all over 34.2 is equal to the sine of B. So the first thing you want to do is you want to solve this and simplify it. So simply put it into your graphing calculator or scientific calculator, depending on what you're using. And this should spit out an answer. Now, it should spit out a fairly lengthy answer. And so when you're working, you need to kind of know when to pull back on your decimals. Alright, so I went ahead, I used a scientific calculator here. As you can see, here is my 42 sine of 45. I did it there, but you get this really long decimal. You get this 0.87951169, and it's possible that that could keep going. So one of the things that I would do is I would keep this value, this decimal digit here, in my calculator to take the inverse. So what's going to happen is we're going to look at the inverse sign of that decimal, 0.8795, to give me the angle for B. So we're going to go do the inverse, use that decimal as is. Okay. So on my calculator here, I have this inverse and sine on the same button, so I just simply clicked it twice to give me the inverse. Inverse has the -1. Then I input the decimal that I had simply by selecting the answer, and notice I get this right here. Now, if you look at the one and only degree we have, it goes to 1 decimal place. So I would round this 61 to 61.6. So what we found here is we found that angle B is equal to 61.6 degrees. Now, we have to be able to check and see if this is a 1 solution system or if this is 2 solutions. So one of the things that we want to go ahead and do is we want to walk through these steps here. I was trying to think of the best way to kind of explain it. So, steps for 2 solution check. Okay, this is what we're going to do. So what you want to do is, the first thing you want to do is you want to take 180 degrees minus the angle you found and see what that equals. Okay, so for us, let me go ahead and pull my calculator over just so that you can follow along. So I would take my 180 degrees, I'm going to subtract away the 61.6, and that gives me 118.4. So when I do that, this gives me 118.4 degrees. So the second thing that you want to do is you want to take your given angle plus, we'll call it the new angle, and you want to make sure that this is less than 180 degrees. So my given angle would be the angle in your problem. So for us, it's 45.6. So my given angle here would be the 45.6 degrees. And I want to add that to 118.4 degrees and see what happens. Okay? So I'm going to take this and add 45.6, hit enter. Notice this is 164. Okay? So here's your rule. If the angle is less than 180 degrees, then you have 2 solutions. If the angle is greater than 180 degrees, then you have either 0 or 1. Okay? So those are the steps that you need to take in order. So for us, we came up with 164 degrees. This 164 is less than 180. Therefore, we have a second solution, and the 118 would be that second triangle. Okay, so we're going to get to that second triangle here in a second. We need to finish out the first one because all we have found so far is angle B. We still need to find side A and angle A. So now that we have angle B, we can find angle A. Angle A is found by taking the 180 degrees minus what was given, 45.6 degrees, minus the angle you just calculated, 6 degrees. And that is going to give you angle A. So here angle is going to end up being 72.8 degrees. Now that you have an angle A, we can use the law of sines to finish the problem out. So now we're going to have A over the sine of 72.8 is equal to 34.2 over the sine of 45.6. So here A is going to be 34.2 times the sine of 72.8 all over the sine of 45.6, which in this case is going to give us 45.7. So if you look, we've got our 3 answers. We have our angle B here, we have our angle A, and we have our distance A. Now remember I said we had that second solution, and so we have to solve that second solution. So in this case, now we have solution number 2, which is that angle B. So now we have that angle B is going to be 118.4 degrees. So with that, we have to be able to now resolve for everything. So to find angle A, says again, we're going to take 180, subtract the given angle, 45.6, subtract the new angle, 118.4, and this is going to give us 16 degrees. Then we can find our new side A. So we have A over the sine of 16 is equal to 34.2 over the sine of 45.6. And in this case, we would find that A is equal to that 34.2 sine of 16 over the sine of 45.6. And so in this case, we would have that A equals 13.2. So notice again, we have 3 new answers. We also have angle B, we have angle A, and we have my side A. Okay. So that's the law of sines in a nutshell. If you have any questions at all, please feel free to let me know. If you have any other examples that you would like me to work out for you, let me know that too. I'd be happy to work those problems. Just remember, in order to use law of sines, you have to have one side length for sure and 2 other measures. Okay? I hope you enjoyed yourself, and I look forward to seeing you next time.